Next, we're going to find the youngest age and the oldest age of these two populations. Now, we know that the average is the same for infected versus not infected versus the entire population as a whole. We know that the standard deviation is different between the infected and not infected population. But let's look at what the youngest and the oldest is. Because of this clustering of the age and the standard deviation being so much more narrow for the infected population, we could kind of expect the youngest age to be and the oldest age to have a little narrower of a band than the not-infected population. But let's prove that out. So we're going to find the youngest age for the entire population. So we're going to do an equals min, and that's going to give us the smallest number in a set of values. So we're going to go min and we're going to go min and age. Next, we're going to go max and age. Now, I didn't want to go younger than 18 for zombies because that's a downer to think about kids getting infected. And then 64, I don't know, I guess downer for elderly too. But now let's look at the youngest age for a specific set of the populations. We're going to do min, and we're going to use our friend MINIFS, and this is going to give us our formula. And so there's a min range, criteria range, and then the criteria. So our min range is going to be the age. Our criteria range, well, our criteria is if they're infected or not. So we're going to do that. Criteria range 1 will be column D, and then the criteria, we're looking for yes. All right, so the youngest infected person is 34 years old. So to find max, we're going to do max ifs. And we're going to do very much the same setup. 49. Okay, now in the previous video for standard deviation, I said that 68% of the population should be within 4.6 years above or below 41. And well, we found that the youngest is 34 and the oldest is 49. So that seems to be kind of holding true. 68% of the population would be around 37 years old, and it starts to trail off the farther you go out from that average. So that's interesting. But that's the formula to do that. So you're going to apply that same formula to infected no, and we're just going to copy that because we've already done most of the work creating the formula. And we're going to put a no in there, and you could probably guess that the oldest is going to be 64, and you would be right, 64. So again, this points to there is a difference in the age characteristics of these populations despite the average being identical.